Hello, my name is Jack. Joining me today are my colleagues Rebecca, Lauren, Thomas, and Michael. And today we're here to introduce SolarEV, a project dedicated to creating innovative solar-powered charging solutions for small electric vehicles. This project will provide a solution for the developing infrastructure for small electric vehicles. The solution will offer a solar-powered option for charging these EVs at both an individual and a community level. The goal is not only to offer more energy efficient solutions, but also to modernize and expand infrastructure by integrating clean energy solutions. Moving into the background, as urban areas increasingly embrace micro-mobility solutions, the demand for convenient and sustainable charging infrastructure has surged. The solar-powered charging station addresses this need by integrating photovoltaic technology to harness sunlight, converting it into clean energy to power the charging units.
Moving into the technical highlights. So for the system overview, the goal is to create a system to charge small electric vehicles. Our components in our design are a solar panel, charge controller, lithium-ion battery, pure sine wave inverter. We have charging cables, and then our overall housing for the components.
So our selected housing design was based on different conceptual designs that the team created, and after various criteria were implemented, this one selected housing was chosen. And after different CAE analyses, including structural and thermal, the design was analyzed in different orientations, including a max stress analysis and thermal analysis, which verified the need for ventilation and cooling. So some key system features that are important to our design include a solar tracking capability where it'll optimize the solar panel based on light and solar angle, weather and environmental resiliency to combat inadvertent loads and extreme weather conditions, some interactive charging features to monitor the amount of battery in the system, and finally some security features including a locking system and emergency shut-off capability to combat system overheating.
Now moving into the project schedule. So this is the project timeline. We have completed up through phase 3, and the next phases include prototyping for roughly a month, and then 2 weeks of troubleshooting and testing, and then a month of final reporting and edits before the Design Expo on May 9th. The goals of the next phases of our project are to design and develop the machine housing, design and develop a functioning tracking system, and incorporating the other key features that were talked about by Thomas, and also developing the alpha and beta prototypes further.
For the cost and funding of our project, our original budget is $700, and as seen by our bill of materials between the battery monitor, the solar starter kit, the converter, and the lithium battery, we're left with roughly $110. So for our future anticipated costs, we plan to use acrylic, and with our specific design, this will come out to roughly $750. And when adding it to our 3 other anticipated costs, we would need roughly $1,350 to fully execute this project to the best of our ability.
Thank you very much.